Welcome back, guys. I'm going to go over something that I've been working on, and it's been mostly in Tinkercad for the last little while, so there wouldn't have been a way for you guys to really see it. And I'm trying to watch the screen on my phone and not the screen on my laptop to make sure nothing goes off view for you guys, because it is kind of a big object, and that's the first thing I'm going to talk about right now. If we can get this to stay in focus, of course. Oh, I think we lost our focus. Let me just double check this. Yeah, we want it to be just a touch out of focus. And then bring it back in. There we go. Well, hopefully that looks alright. We'll find out in a minute. What we have is this funny mark at the top. That's the height of the raw stock. Above this is the height that I need. Above is the raw stock. This also happens to be the zone where everything above that, Tinkercad will chop it off if you perform one of its Boolean operations, and I believe that's 600 millimeters high. I'll have to double check that later, but I'm pretty sure that's 600 because these rods are for something. The rods are all salvaged from various 3D printers and flatbed scanners, with the exception of these thinner rods, which represent the lead screws, which are like, I think they're just Acme lead screw. I picked them up from Princess Auto. This is an aluminum bed. I might have a video about that separate, but again, that was an aluminum bed that was marked for recycling, and I managed to get it, and it's going to work just fine for what we need it for in a printer. As you see here, I've got these would be the y-axis rails. They are to size scale, but there's a little bits of funny shapes at either end because they came out of a printer. So I'm not sure if I'm going to leave those on or cut them flush like they are here in the model. This piece of wood here is the cutout wood from the back, this back frame, and this back frame, it's a very high density pressed like lithograph picture that is not going to be used anymore. So again, it's recycled, but it's a very, very dense press wood. And when I cut out the hole that will allow the z-axis travel, the piece of wood that's left over is going to make this bottom frame. The parts you see here are wood, and I believe they're 1x2s. I'm going to have to double check that, but as you know, dimensional lumber isn't the real size. But in Tinkercad, that's their measured real physical size. And in the back here, I have some metal brackets I'd salvaged and changed and made up before that will go between the bottom of this frame and there, and I'll probably use one of the holes that's drilled in it to run a piece of threaded rod from one side to the other to help support the bottom, because it's going to be open. This will basically be a giant upside down U. Let's see if I can come out here. This will basically be a giant upside down U, so that will help me set the bottom distance and keep the gap proper. And then here I was just looking at possibly bringing a brace up from the back of this to something here on the board, but I haven't quite got into that because that's only going to be easy. That's really the easy stuff. The complex stuff were these 3D parts. Now just about everything you see here has been printed out already, with the exception of the newer stepper mount. I did a retake on how I was going to mount my stepper to the board and hold the rods and everything, and I came up with this mount here. I'm going to see if I can bring this front and center. Ooh, it's a little bit big, but this little fella here is designed to hold the stepper, and then there's a second piece which is the same profile as the bottom, which is printed, and I can adjust that piece to bring out the correct distance to clear the x-axis gantry from the board. Rather than print the whole mount piece over again, I can just print that spacer. Then up here, these top parts, these upper bushings, I actually printed them. I'm going to grab one and see if we can get this in focus here. You can see where I've got my temporary tester bushing sizer. It's just a segment of one of the PLA bushings I'm using. The thing with this is, that was printed in the PLA Plus from Rigid.ink, and it is dimensionally perfect to the file. That makes me want to order a nice big roll of that stuff. There was a tiny bit of shrinkage on the base, But the upper stuff, this upper stuff, sliced in Cura and just done on my Fabricator Mini, everything on it is dimensionally perfect, even after, I guess it would be the shrinkage, to what was in my file. So that's interesting. I might do a separate video on that later if I get another part like this to print. But I printed both of those. Here's the other one. I printed the both of them, and they're probably not showing up because they're being backlit by that screen too much, but they came out really quite well. They are the parts. That's this part here. I'm just going to click one and highlight it. That holds the bushing on the top of this 3D printed monstrosity here. And these I've already printed out, that yellow part. But that was this part here that was just, I was just showing. And that holds the upper bushing to keep the x-axis nice and flat as it moves up and down the z-axis. One of the things, after thinking about this last night, when I was at work, and I was looking at how I did this, which has the L channels pointing inward, which makes for a very easy in-running carriage like that, but then there's a very narrow gap of 1.5 millimeters for the belt passing over top of it. Now it'll miss the head of the extruder, I think it's the same. I bought a backup extruder that the Fabricator Mini uses, so it'll be one of those. I just can't remember the name of it. It's like an E3D V6 clone or something like that. But where these point in, makes it easy for this mounting hole here to connect the motor plate to this. But what it does is it limits the space I had in the middle. So what I was thinking is, if I reprint this later, I'm going to invert these rails so that the narrow point in here points outwards, and that the runners will run on the outside of the rail. And I might also, if I do that, I might also convert this to be more standard, where these two bars are arranged vertically instead of horizontally. So it'll look like an arrangement of a pretty normal 3D printer. We'll have a look. We'll see how this works, because let's face it, the PLA that these parts were printed in was leftover PLA that a friend had gave me. So there's no, I guess essentially that's also recycled too. So it's first-hand recycled PLA, but it was still on the roll. So we'll see. I have to figure out the mechanism on the end for the belt tensioner on this side. It's an idler pulley that is going to tension the belt. And if I can bring this down where we can see it, you can see the narrow gap, which is plenty wide enough for the belt to travel, that the belt will pass through. The belt is a T2 belt, and it should pass through that gap there just fine. And then I will print an idler pulley here, although I have some V-grooved bearings that are the right dimension for the belt to go around, just not toothed. And if I just stack two of those with a PLA spacer in the middle, that should make for a very free spinning idler pulley on that end. And I'll probably do that. That'll probably be what I end up doing, because it's easy, it's leftover parts, and it's easy being the important part. I just have to figure out the tensioner mechanism that'll slip over the top of that'll hold the axle that the idler pulley sits on. But these parts here, this again is just a mirror of the opposite side, functions to hold the stepper motor at the bottom, or technically it could be holding, the way it's built, just as easily the stepper motor at the top. Depends on which way I decide, but right now I have plenty of room to fit a stepper motor in the bottom, and that should work pretty well for holding that. So once I get this one up and running and we see how it goes, if it even works, I'll go from there and probably make a second iteration and try changing these to be inverted. Instead of pointing inwards, they will point outside, and I might even change them from being across the horizontal plane like this to be up and down on the vertical plane, so it would be look more like a standard 3D printer's linear rails for the x-axis. and then it would be an L-shaped part coming off the front of that to hold the print head. But I'm not planning on using this for CNC or anything else. This is just going to be a lightweight Bowden style extruder over to an E3D V6 style print head. One of the little things you've probably seen on the front are these blocks that are holding the 8mm rods. And this is a file I've had up publicly on Tinkercad for a while, and I'll put a link below. And it goes up and over and captures the rod on the top and gives you a space for an M3 bolt and nut or even screw to pass through the middle. And I'll just spin over here to this one, zoom in, and lets you clamp down your 8mm rod. Now there's another 8mm hole at the bottom that doesn't really clamp, but it would be a pretty tight fit to 8mm. You could pass the 8mm rod in it. You wouldn't need any tools or anything, but it's a pretty tight friction fit on standard 8mm rod. But the idea of that would be is if you were going to use this with a threaded rod frame or something like that, you could pass it through there to double this up for rigidity if you needed it. And then a couple simple mounting holes go down into the board. And that board, of course, is just a piece of the cutout center from this. And the distance of these rails, which came from all the 8mm rail here is recycled from old inkjet printers. The rail here that you see this board mounted on provides enough movement for it to pass center plus about 2 centimeters, so it's more than this print bed needs for movement. And that's with what the only thing I don't have drawn in here are the PLA 100% PLA pillow blocks. So far they're working really well, lubricated with silicone paste, a pasty grease. It's actually dielectric grease, but it's made out of silicone. But it works awesomely with PLA on smooth rod, and I'll probably do a quick video about that later when I get the pillow block modeled for in here. When that gets done, I'll go over how I mounted them to the plate, and it's really just a matter of lining up the holes, drilling holes, keeping everything pretty lined up, but giving yourself enough wiggle room for the tiny little bit of error that can happen. The only thing that I'm a little bit hesitant with this is the holes that go down for attaching these. I'm going to actually have to make them tiny little slots to give each one about a millimeter or two of play, so that I can adjust these in and out to get the rails perfectly lined up, so there's no extra friction on the print bed. And then there'll be a Mark II heated print bed on top of that. At least that's what I plan, if I have the stuff to do that, if you've seen the other video. But this is where the mechanical design is at now. And yes, this video went a little bit longer, probably a little bit more wordy than I intended, but for a couple of you mentioned, and on a couple other places that I haunt on the internet, had mentioned they wanted to see where I was at with my design. And that's the design. Some of these parts exist now, like pretty much everything except for the bottom stepper motor mounts. PLA is done, and the idler pulley, almost all the PLA is done. It's just going to be a matter of cutting this board out accurately and trimming off this wooden stock to the correct sizes. These metal brackets, I haven't modeled them 100% how they are in real life, but I will show you those when I get around to actually building this frame. And I'm hoping sometime in the near future I will have the work started on the frame, and we'll go from there. And I think I mentioned already, above this line here where it goes transparent, I've just put this Tinkercad hole block to remind me. From this line up, this would still be the raw material, but Tinkercad does not do Boolean operations on something larger than 600 millimeters. So from the bottom to the top of there, that's 600 millimeters. So that should give you the idea of the height of this. And I'll just be using one of those ramps board kits from China that seems to be functioning to run everything, and we'll see how it goes. So anyhow, long-winded, I know. I apologize for being kind of long-winded. And again, I'm pretty sure you can hear the air conditioning running in the back, but it's actually, for here, it's quite warm and unfortunately extremely humid right now. So I'm actually avoiding doing anything with the wood at the moment. Kind of don't want to cut the wood when the humidity is up like this, because if I do, I got to cut everything at the same time. But that's another thing. Anyhow, if you have any questions or comments, don't forget to put them below. And if any of you want to see the Tinkercad links to any of these parts, as I have them available, I'll be putting them up in my Tinkercad public files. And as I finalize them, they'll show up there. If they're not quite finalized yet, I won't be putting them there unless somebody specifically wants it. And if somebody's building a machine along with my parts, just let me know. It would be kind of cool, but I don't think anybody else is crazy enough to attempt it this way, because you know, there's a few things on here I'm second guessing, wondering if they're going to work, but I'm doing it for the sake of an experiment for those that have followed my L channel rails. So let's hope this works out. This is where I am now. So if you like these kind of crazy experiments and ideas or whatnot, don't forget to hit that like and subscribe. It lets me know that there are some people watching and like this kind of crazy stuff. And as always, thanks for watching, and I'll see you in the next video.